Today we're going to start a rather tricky topic. We're going to be talking about this for a couple sessions. This is not just a one-session thing, so don't expect a huge amount of practice yet today. The topic is recursion. This is an old joke in computer science. One must first understand recursion in order to understand recursion. Well, by the time we're done talking about this today, you'll have a pretty good understanding of why that's a good joke. So, we've talked about this story before, I believe, but if you want to count the number of people that are in front of you at the Statue of Liberty, what you do is very simply, you start at the bottom and you ask the person in front of you, how many people are in front of you? That may not seem very effectual, but if that person asks the person in front of them, it says, how many people are in front of you? And then that next person asks the person in front of them, it says, how many people are in front of you? And they keep asking that question over and over and over again until they get to the top. And the person at the top says, well, there's nobody in front of me. And he turns to the person behind him and says, there's nobody in front of me. So the person behind him then adds one and says, there's one person in front of me. And turns around and tells the person in front of them and says, there's two people in front of me. There's three people in front of me. There's four people in front of me. And then all the way back down the staircase to the person at the very, very bottom who asked the original question. That is the general premise of recursion, where you start at the bottom, work your way up or down, however you want to look at it, a set of stairs, until some ending condition is met. And then you cycle all the way back through to the starting point, doing some type of iterative calculation along the way. As a general rule, anything you can do with recursion can also be done with loops, because it is an iterative process. It's just recursion, the code is so much more elegant. Requires so much less work. Imagine if you were trying to figure out the number of people on a set of stairs on the Statue of Liberty. Yeah, you could count them, but that would require you starting at the bottom and kind of shoving your way through all the way up the stairs and walk all the way up to the top of the stairs, saying, pardon me, just counting the number of stairs, just counting the number of people, counting the number of people, all the way up to the top, and then finally getting to the top and say, oh, now I know how many people there are, then walk all the way back down the stairs to your spot in line because you can't cut in line. Yeah, you could do that. But it's not really as elegant a solution as the recursive solution. So it's a method that repeats by asking the same question over and over again. Or another way of saying that, it's a method that calls itself. So in our case, for the Statue of Liberty, the method would be, how many people are in front of you? How many people are in front of you? So the question we're asking in this case is, are you at the top? Until we get to the point that we are actually at the top. That's our question. Are you at the top? Nope. 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 Are you at the top? Yes! Nobody in front of me. One person in front of me. Two person in front of me. Setting it all the way back down the line. So picking up that good question that will end your recursive loop is important. So here's a really straightforward example. We have a method declaration. Its signature is that it takes an integer. It's static, so we don't need to create any classes. We can just use the method name inside the same class. It's void. It doesn't actually return anything. Most recursive functions will return something, so that way you can keep track of it. But this one doesn't. This is just demonstrating a very simple example of how recursion will work. And it says, if n is greater than or equal to 10, then call print decimal n divided by 10. So that comes back up to here. And we're sending it the value from before divided by 10. So if I started with let's say I started with 1,000, make it easy. Start with 1,000. 1,000 is greater than or equal to 10. So we're going to call print decimal with 1,000 divided by 10. That result would be 100. So we come back up to here and say, all right, call print decimal is 100 greater than or equal to 10. Yeah. So call print decimal with 100 divided by 10, right? So we call print decimal with 100 divided by 10. Well, that's 10. Come back up here. Is 10 greater than or equal to 10? No. So then print decimal, system.out print line mod and mod 10. So we're going to do 10 mod 10, which is 1. But now we're done calling the method, right? The method is over. When the method is over, it returns the call back to the statement that called it before, which is right here. So the next thing it does is it prints out n mod 10. So the last number was 100. So 100 mod 10 is 2. Now we return back to here again. We finished it. So now at 1,000. 1,000 mod 10. 3. So we walked all the way down until we hit the limit, till this condition was true, or actually false in that case. Once it was false, then we started cycling our way back through the whole method. Do a little bit of a trace here to kind of really understand what's going on here. So if we imagine print decimal as this box, okay, let's just call this the actual first method call, and inside the box we put 1,000. Okay? And then we go inside the box to the next box. Well, the value that goes into the next box is 1,000 divided by 10, which is 100. Then we go to the next box because we do it again, right? It's still greater than or equal to 10. And we get down to 10. And we divide it by 10 again, one more time, and we get down to 1. Okay, so now our condition clicks. 1 is not greater than or equal to 10. So what happens next? Well, what happens next is a print on the screen, n mod 10. Well, 1 mod 10 on the screen, say this is our screen, is 1. The method has ended now. When methods end, they return control back to what called them. So this method is now ended, right here. Control is returned to there. So now we're back at the 10. We've completed this method call. N is 10. We've completed this. The next line is to print out 10 mod 10. Well, 10 mod 10 is 0. Right? No remainder? Did I do that right? Okay. 10 mod 10 is 0. Finish that method call. So now I'm going to return control back to the last thing that called it. Was the 100. So I'm here. N's 100. It says print out 100 mod 10. 0 again. Finish the method call. Go back up to here. 1,000. 1,000 mod 10. Print it out. 0. Go back to what I called it originally was probably down here in main. So recursive methods have a call to itself and a base case. Those are the two things that are required for any recursive method. So if you're looking at an AP computer science test question and you see the name of the method inside the name of the method, you know you're dealing with a recursion. Hold on to your hats. Right? You know at this point you're going to have that kind of stair step mentality where you're going to have to go back up and back down. You need to kind of get into that mode of tracing it. There must be a base case. At some point, usually it's some type of if statement. So identifying what that base case before you do anything is important. What's going to stop it? So a stack is another example of a recursive structure, because a stack is a spot in memory that holds information in like a stack of papers, like a pile. So when you create these additional methods, when you call these methods over and over and over again, something has to keep track of them because they don't close. They're waiting for some information to happen, but that can't happen until the other method finishes, and that method can't finish until the other method finishes, and that method can't finish until the other method finishes. So we need some type of structure to hold all of that together, and that structure is called a stack. Once the base case is hit, then the program can travel back through the stack. Or staircase. Stack is the word we use in computer science. Often I use the word staircase because it's a good analogy. You can get a stack overflow. If your recursive algorithm, and you may have heard this before, stack overflow, right? If your recursive algorithm goes on too long and your stack can't keep track of it, then the whole thing collapses. So here's another example. It's called recursive 1. It has a parameter of an integer. We can know this is a recursive method because it calls itself right here. The base case is n greater than 0. That's what's going to stop the loop. Once it stops the loop, the thing that actually happens is it will start printing out the values of n, one at a time. So here's the question. Trace this and figure out what happens on the screen when we do recursive 1.6. I want everyone to give that a try. Pause the video, give it a shot before we go over it.